Hi, I'm Brian Schmidt, an astronomer here at the Australian National University.
And I'm Paul Francis, and we'd like to welcome you to this course on the violent universe. In this course, we're going to go through all the most deadly places in space, ranging from white dwarf stars, supernovae, novae, pulsars, neutron stars, all the way up to giant black holes.
I love this part of the course, Paul, because I study stars that explode and figure out how we can look at the universe itself with these stars.
And I study the giant black holes that live in the middle of galaxies, so this is close to both our hearts. Let's show you how this course is going to work. You will spend most of your time when doing this course in the Courseware tab up here. Each week a new section will be released. The two crucial parts of the section are the lesson and the homework. So here's lesson 1, and it consists of a bunch of videos interspersed with questions. There are a whole lot of controls below the video which you can play with. For example, you can turn on or off the closed captioning, and you can download the video and the transcript. If you have any questions about the video, you can post them right below where there's a discussion specific to that video, or you can go to the discussion tab and post something there. After each video there will be a question testing what you've learnt about the video. The other thing you have to do each week that's really important is the homework assignment. You have 2 weeks to do it from when the lesson is first available, and this will consist of a whole string of questions. In addition to these compulsory parts of the course, the lesson and the homework, there are also reference notes which give you an easy way to check back on the key facts. There are worked examples and practice questions to allow you to get some practice in doing the homework before you get to the real homework. And in addition, there is a mystery. Week by week we will build up the story of a mysterious and different universe, and your job is to try and find out what's going on here. For more information, you'll see a course guide, syllabus, the combined reference notes and printouts of all the transcripts over here on the course information page, and there will also be regular updates of course news.
To successfully undertake this course, you're going to have a working level understanding of high school maths and physics.
There'll be a little bit of calculus in some of the videos, but you won't actually need it to get any marks or answer any of the questions. What you will need to do is a lot of what we call back-of-the-envelope calculations.
So a back-of-the-envelope calculation is where we try to estimate the physics of a problem to an order of magnitude, just to figure out whether or not it's interesting to pursue.
There are 2 reasons we do this. One is to allow us to really focus on the core physics of what's going on without getting just bogged down in factors of 2 and pi and
yeah, we don't care about
details.
Factors of 2 in astronomy, do we?
But the other reason is that it's a really important skill. When you're doing almost any research project, you discover something new in space, your first step is to do a back-of-the-envelope calculation. You're often sitting in the bar thinking, could it be this, could it be that? Quick calculation. Most of the ideas die immediately, and then if you get the few that survive that first step, you can then do the detailed calculation.
So every day, Paul and I would go through, and when we have an idea, we do the back-of-the-envelope calculation to make sure it was a reasonable idea. You don't want to waste your life doing things that you know in a few seconds with the back-of-the-envelope calculation are wrong.
Okay, so now let's start the course.